I want to look at this example where we have a function describing the position of a particle along a linear path at time t, where the time is measured in seconds and then the position is measured in meters. So when you're talking about position of a particle on a linear path, there's just some sort of intended like marking where you kind of think about there being a direction. There's like some zero mark oftentimes is like regarded as where you're starting. And then you can have a notion of what forward means and backwards means. Okay, so in this case, the function is given by t cubed minus 6t squared plus 9t. And I just want to actually play the motion of the particle for the first 8 seconds so that you can kind of see how this plays out. So I'm going to go ahead and play it and just kind of pay attention to what the particle is doing, the motion of the particle. Okay. So we can actually look at specific points in time. Like we can look at where t equals 2 and we can calculate what is f of 2. And after 2 seconds, the position is 2. So that means it would be 2 meters along the path. So, and if I was to look at when t equals 6, say, oops, how about 5? 5.5? Yeah, let's do 5.5. At t equals 5.5, f of 5.5 is 34.375. So that's the position of the particle. Okay, so this is sort of as I drag or as I let time pass, this really is mapping the position of the particle at each of those given times based on that function. So when we look at this, we might think about describing this motion. And so I'm going to play it one more time and see if you can think about how you would describe the motion of the particle. So let's talk about like how would we describe the motion of the particle? And a lot of times, people might describe it as it moves forward and then backwards and then forward again. And so a lot of times people might think that they notice it seems to be speeding up as it continues moving forward, or like at the end of that time period, it looks like it's speeding up. And there might be some questions of, at what time does it turn around and come backward? How far does it go before it turns around? So these are some questions that we might be able to answer. And it's important to kind of think about like, how can we quantify movement? Okay. And I'm going to put out the question, what is movement? Thinking about that, movement is really a change in position. And so when you're talking about moving forward, that means that the change in position is an increase in position over time. And thinking about increasing the position over time, where the position is given by this function f, increasing f over the span of its input variable is really talking about a positive derivative. Okay, so moving forward means that the derivative is positive. F prime is positive, right? And similarly, moving backwards means that the derivative f prime is negative. So what we should be doing is we should actually be looking at what the derivative is of f. So I want to take a little look at this and see what is the derivative of f, and when is the derivative positive and when is the derivative negative. Okay, and that will be able to tell us on a time scale when the particle is moving forward and when it's moving backwards. So I'm going to do this, and I want to do f prime of t equals, so the derivative of f, this is a polynomial, so it's pretty easy to take the derivative. So the derivative of t cubed is 3t squared. The derivative of negative 6t squared is negative 12t. And the derivative of 9t is just 9. Okay, so we're going to ask when is f prime positive and negative? And so in order to answer that, first we need to find out when f prime is 0. Okay, so let's go ahead and factor it. F prime of t is going to be, there's a common factor of 3, so I can do 3 times t squared minus 4t plus 3. And then we can factor that t squared minus 4t plus 3 into t minus 1 times t minus 3. So we have f prime of t equals 0 when t equals 1 or t equals 3. So in this case, I'm really only looking for t greater than or equal to 0. So I'm going to look at basically 3 time intervals: the time interval from 0 to 1, the time interval from 1 to 3, and the time interval beyond 3 seconds. So there are 3 time intervals. So if t is between 0 and 1, then what we have is f prime of t is, this is 3 times t minus 1 times t minus 1. And if t is less than 1, then t minus 1 is a negative number. And if t is less than 1, then t minus 3 is also a negative number. And 3 is, of course, a positive number. And so a positive number times a negative number times a negative number is a positive number. Okay. So for the first second, the derivative of the function is positive, which means for the first second, the particle is moving forward. The change in position is a positive change. It's increasing. Okay. So now let's look at if t is between 1 and 3. So f prime of t, again, is 3 times t minus 1 times t minus 3. So that 3 is always positive. If t is bigger than 1, then t minus 1 is positive. And if t is less than 3, then t minus 3 is a negative number. So then in that case, that would be a negative number. Okay, so in that case, for t between 1 and 3, the particle is moving backwards. And I should put that up here. For t between 0 and 1, particle is moving forwards. Okay. And finally, for t greater than 3, f prime of t again is that if t is greater than 3, this is still a positive number. 3 is always a positive number. And t is greater than 1, so t minus 1 is a positive number. And if t is greater than 3, then t minus 3 is also a positive number. So that would be a positive number. So that tells us for t greater than 3, the particle is going to be moving forward. So I'm just going to copy this and paste it. For t greater than 3. So let's see that here. So it says for the first 1 second it's moving forward. Let's see that. Okay. And then from 1 to 3 seconds it's supposed to be moving backwards. Let's check that. Yep, it's moving backwards. 3 seconds. And let's see that it moves forward after that. Yep, and continues to move forward. So it might be the case that you might have actually watched this initial motion and asked yourself, what's going to happen after 8 seconds? Is it, and what's happening over there to the right where we're not seeing it? Is it continuing to move forward? Is it moving backwards at all? Is it ever going to come back to where we can see it again? And this actually answers it for us that since the derivative is positive for all t greater than 3, it's never going to turn around and move backwards again. It's always moving forward. So we're never going to see it again. Okay, at least not in this viewing window. We'd have to zoom out in order to be able to see it again. So this actually gives us some really good information that about the motion, that it's moving forward for the first 1 second, and then it's moving backward for the next 2 seconds, and then it's moving forward from then on. So then we could actually see, like, what is the position at each of these places where it turns around, right? What is the position when t equals 1? So we could actually ask, what is f of 1? Okay, and f of 1 is 4. So that means it moves forward to the 4 meter mark. And then at t equals 3, it looks kind of like it moves to the 0 mark. Let's see. F of 3, that's 0. And of course, you can also plug this in by looking at the function. You know, if you were to plug in f of 1, that would be 1 cubed minus 6 times 1 plus 9. So that's 1 minus 6 is -5. -5 plus 9 is 4. Okay. And of course, you could also plug in t equals 3 and you should get 0. Okay, so now we can actually see that the particle moves forward for 1 second and it hits the 4 meter mark after 1 second. And then it takes 2 seconds to go back to the 0, the starting place. And then after that, it's perpetually moving forward. So in fact, at this point, we can ask we can answer, there's some questions from the book. There was the question, when is the particle moving forward? And so now we know. We can find the velocity of the particle at 2 seconds and at 4 seconds. And the velocity is really the derivative of the position. That f prime of t is velocity. Okay, so we could say I can copy that, this is velocity. I'll call it v of t for velocity, okay? All right. Oh, but so there was this question of find the total distance traveled by the particle during the first 5 seconds, okay? And if we want to do that, well, what happens? So I go forward by 4 meters, and then I go backward by 4 meters, and then I go forward, how many? It looks like 20. Let's see, what is f of 5? 20. So you can actually answer that question. So we go forward 4 meters, then backward 4 meters, then forward 20 meters for a total of 28 meters traveled. So the total displacement is 20 meters. So if there were a string attached to the particle, then that string would only be stretched out by 20 meters from the starting point. But the total travel distance of the particle, you know, the particle had traveled a total of 28 meters because it went 4 meters forward and then 4 meters backwards and then 20 meters forward. And so here's another thing. We had said that it looks like it's speeding up. And we could ask, like, what does that mean to be speeding up? Speeding up that's changing its velocity. And so we're talking actually about a derivative of velocity. So the derivative of velocity is what we call acceleration. So if I want to look at v prime of t, I want to take the derivative of velocity, so that's 6t minus 12. Then I can factor out the 6 and it's t minus 2. So we can actually see the velocity is going to be, sorry, the acceleration, this is the acceleration, is 6 times t minus 2. So the acceleration is going to be negative if t is less than 2 and positive if t is greater than 2. Right? So putting that together with the other information that we have where the velocity is positive for the first second and then negative for the next 2 seconds and then positive for the following, like for the rest of time, let's actually put that together. So what we have here is, let me see, for the first second, the velocity is positive, right? And the acceleration is negative. So that means the velocity is positive, means that the particle is moving forward. But since the acceleration is negative, that means it's going to be moving forward at a decreasing rate. So the velocity is positive, but it is becoming less positive. You know, thinking about the velocity being positive, but if the acceleration is negative, that means the velocity is decreasing. So it's becoming less positive. It's getting closer to 0. So if you think about what that means, you should get that the particle is slowing down. Okay. Now, for t between 1 and 2, let's see, the velocity is negative. And the acceleration is negative. So the velocity is negative. That tells you that you are moving backwards. I should have said in the first part, the particle is moving forward and slowing down. So in this case, the particle is moving backwards because the velocity is negative. And since the velocity is negative, okay, and the acceleration is negative means the velocity is decreasing. And if you have a negative function that is decreasing, then it is getting farther away from 0. So it's becoming bigger negative numbers, right? If the velocity is negative and decreasing, the acceleration is the derivative of the velocity. So if the acceleration is negative, that means the velocity is decreasing. And if you have negative numbers that are decreasing, they are getting farther away from 0. So they're becoming bigger negative numbers. So that tells you that the particle is actually speeding up. Okay. Now for the next 1 second, so I just want to kind of reiterate the reason why I'm splitting the time into these increments. Remember, from t equals 0 to 1, the velocity was positive. And then from t equals 1 to 3, the velocity was negative, and then after t equals 3, the velocity was positive. So 1 and 3 are kind of the breaking points for velocity changing direction. And then t equals 2 was a changing point for the acceleration changing direction. For t less than 2, the acceleration was negative, and for t greater than 2, the acceleration was positive. So that's why I'm splitting into these intervals. This is the last finite interval that I'm going to do, and then we're going to look at the t greater than 3. Okay, so for t between 2 and 3, my acceleration has now changed to positive, but my velocity is negative. Okay, so think about what this means. The velocity is negative. That means that the particle is moving backward. Because the velocity is change in position. So the position is decreasing. Okay, so if the velocity is negative, then the particle is moving backward. And the acceleration is positive, so the way that the velocity is changing is against the direction that the velocity is moving. And thinking about a function that is a negative function, if its derivative is positive, then it's increasing. So if the values are negative and increasing, those values are getting closer to 0. Which means they are becoming smaller negative numbers. So the smaller negative numbers means that the particle is slowing down. So keep in mind the velocity is really a speed plus a direction, okay? So when I say the velocity is -2, for example, in this case, our time unit is in seconds and the position unit is in meters. So if the velocity is -2, that means the particle is moving backward at a rate of 2 meters per second. If the velocity is, say, 7, then that means the particle is moving forward at a rate of 7 meters per second. If the velocity is -20, then that means the particle is moving backward at a rate of 20 meters per second. So the absolute value of velocity is the speed. And the sign of the velocity, the positive or negativeness, is the direction of the movement. Okay, so thinking about whether the particle is speeding up or slowing down, we're really thinking about what is the absolute value of the velocity. Is the velocity getting closer to 0 or farther away from the 0? If it's getting closer to 0, then it is slowing down. And if it is getting farther away from 0, then it is speeding up. Okay. So finally, for t greater than 3, in this case, the velocity and the acceleration are both positive. So thinking about the velocity being positive, that means the particle is moving forward. And if the acceleration is also positive, so the velocity is a positive number, and it is increasing. If its derivative is positive, then it is an increasing function. So if it's positive and increasing, that means it's moving farther away from 0, which means it's speeding up. So not only is this particle continuing to move forward along this number line, it is getting faster and faster at every moment. Okay, did we answer all of the questions? When is the particle speeding up and when is it slowing down? So yeah, we kind of traced the speeding up and slowing down. Let's go ahead and look at this again. So for the first second, it is moving forward and slowing down, and that's the one where it goes from 0 to 4. And then for the next 2 seconds, it moves from 4 to 1, or 4 back to 0, right? So the first one, it's slowing down, moving from 0 meters to 4 meters for the first second. And then the next 2 seconds, it's moving backward, but thinking about how that movement goes, I am speeding up for the first second and then I have to slow down, which kind of makes sense. You're kind of getting started, so you're kind of going from the like a 0 velocity, pick up some speed, and then halfway through you start slowing down, getting ready to turn around again. And then after that, you're just speeding up for the rest. So I want to just take that and play that out again. All right, so there was a lot going on here, and thinking about how we actually dissected this function, we did use the fact, we used that the derivative of position is velocity and the derivative of velocity is acceleration. We used all of those pieces to get the points where when is the particle moving forward and when is it moving backwards, when is it speeding up, when is it slowing down, in order to answer the question of how far did it travel during the first 5 seconds. Like if that was the first question that we were asked, we would have actually had to first answer in the first 5 seconds, how much is it moving forward and how much is it moving backwards. So we still would have had to figure out whether there were any sign changes in the velocity in the first 5 seconds. So there's a lot that went into this sort of analyzing the motion of this particle for the first few seconds.